Okay, we're returning to the review for Algebra 2, Chapter 1, Sections 1.1 to 1.3. And these are just examples from your review. And I might point out that the problem numbers, like number 14, for instance, might be slightly off. So you want to pay attention instead to the instructions and match them up with the instructions of the problems you're trying to accomplish. So this first section, we're trying to find the average rate of change on the interval -3 to 5. What this means is that we're starting at -3 for the first x, and we're going all the way over until that second x is equal to 5. So -3 is over here, and that puts us at this point right here. So let me label that point. It's the point -3, 1. And then over at 5, we're at a height of 3, so we're going to use the point 5, 3. And these are x's and y's now. And the average rate of change is another way of saying the slope of this segment right here. So that's what we're going to do. We're going to find the slope of that segment. And you're going to use the formula y2 minus y1 over x2 minus x1. That's your slope formula. I'm just going to set it up like this. And you plug the points in from the bottom up. So for instance, I'm going to put this second point in first of all, 5, 3. So you put the 5 there and the 3 above it. You could have stuck the other point in first, but I'm choosing to put that in the back, -3, 1. And then you simply simplify the top. 3 minus 1 is 2. And this double negative turns out to be adding 3. And you get 8. So that is a 1/4 slope. And that is the average rate of change from -3 to 5. So we've got our first answer. Now I'm going to go ahead and erase the marks I've made on the graph. And we'll do it again with a different interval. The second interval is from 0 to 9. So the first x is 0. That's right here. So we shade in 0, 3. And then 9 is clear over here at near the right-hand side of the graph. And if you go down to the graph, you get to 9, -1. And so now we're finding this slope. And you can see that we have a downhill slope, so we're going to be expecting a negative answer. So we'll set up a slope here. y2 minus y1, I'll just make pockets for those, over x2 minus x1. And the easiest way to fill these in is just to take the points. I'm going to start with that 9, -1, and fill them in from the bottom up. 9, -1, and the other one is 0, 3. And then you just simplify the math here. So what we have across the top is -1 minus 3. And across the bottom, 9 minus 0. So that's -4/9, the slope of that line. And that's also the average rate of change. Okay, the next one here, we're supposed to classify the transformation of the original parent function f of x equals x squared. We're supposed to decide whether the transformation shown is horizontal, vertical, or diagonal. Well, if you add 6 outside the function on the back end of it, that goes up 6, and that's a vertical change. If you subtract or add inside, it moves it right or left, and it's always the opposite of what the sign does. So that goes to the right 3 units, and that puts it as a horizontal change. We're going to the right. Right and left are horizontal, up and down are vertical. And then on this next one here, we're going 5 to the left and 1 down. And so since you've got the horizontal left and the vertical down, you combine them, and the net effect is diagonal. Picture going to the left and then down. It's like going diagonal. Okay, the next set of problems, they have a different function. We're dealing with the absolute value function, so this is a V-shaped function. And we have to decide whether it stretches vertically or compresses vertically, stretches horizontally or compresses horizontally, and then we're going to describe what actual change happens to the graph. So when you're messing inside, that's a horizontal change inside the bars. And it doesn't behave right. So even though it says times 3, all of the x's in the problem horizontally get multiplied by the reciprocal 1/3, which compresses it horizontally. That's a horizontal compression. And then you tell what happens to the x's. All of the x coordinates in the points of the problem or the graph are times, and you'll notice I'm going to take the 3 that was in the original up there and I'm going to make it 1/3 the reciprocal value. Okay, in the next problem, we're still inside the absolute value bar, so it's still a horizontal, and we have to decide whether it's compressing or stretching. Well, the reciprocal of 2/7 is 7/2. That's 3.5, and you multiply all the x's by 3.5, it makes them further away from the center. So this is a horizontal stretch. All the x's will be multiplied times 7/2 or 3.5. So it's really 3.5 times wider is a good way to think of it. Okay, and the next one we have for the first time here a multiplier on the outside, and that will, anything on the outside changes it vertically. So this is vertical, and the multiplying by 1/2 is trustworthy. We don't have to mess with it. It's going to take all the y values and cut them in half, which brings everything in towards the center of the graph. So this is a compression. And the y values in the problem, the y coordinates, hang on, let me fix something here. That's supposed to be a semicolon. The y's in the problem get multiplied by 1/2. No change there. Unlike the previous two, I didn't take the reciprocal, and multiplying the heights or the y values by 1/2 will make it much shorter or closer to the center is a better way to think of it. Okay, we're supposed to describe the transformations that are in each of these problems and make sure that we do it in order. So the first one only has one transformation. We get that plus 2.5 inside, which moves it left 2.5 units. Adding and subtracting inside moves left and right, and it's ill-behaved or poorly behaved, so plus goes left. Minus goes right, and you do that inside the stuff first because parentheses are done first in our order of operations. And that goes 3 units to the right. And then second is this plus 8 tacked on the end, and that'll move it 8 units up. And it's supposed to happen in that order. Okay, so there's 3 transformations in the next one. We have a times 4 inside the parentheses. Then when you turn your attention outside the parentheses, you do multiplication next, and finally adding and subtracting. So we're just going to list these in order. The first thing is inside the parentheses times 4, horizontal because it's inside the parentheses. Multiplying by 4 actually ends up multiplying all the x's by 1/4, which will make it a compression. All those x's are times 1/4, so they're coming in closer to the center. The second thing that happens is on the outside, so it's vertical. And you can trust this times 3. It's going to multiply all the y values by 3, which pulls it away up and down from this, away from the center. So it's a stretch. The y values are all times 3. And the final transformation here, number 3, is up 2 units. Okay, the last one we have on this little section is one where there's actually 4 changes. They might not be quite so obvious, but we go to the right 5. Start inside the parentheses when you do it in order. If you remember that PEMDAS starts with P because you're supposed to do the parentheses first. And anytime you're inside the parentheses, don't trust the direction don't trust it. So it goes to the right with a minus. And then this is a times 4 out here and later a negative tacked on it. So you want to go, second one here is vertical because it's outside. And multiplying the y values times 4 makes them taller, so it's a stretch. And the y's times 4. And after that, the negative sign on the outside is a vertical reflection. Top and bottom switch places. Vertical reflection. So every y value in the problem changes signs. If it's positive, it becomes negative, and if it was negative, the y value becomes positive. And the last thing that happens here is down 7 units. Okay, we got, let's see here. Next, we're going to describe the transformations that happen and make you write the formula. So if you start out with f of x equals x cubed, that's this first one, and you want it to go 3 to the right, let me do this in slow motion over here. We're going to call it g of x here. You're going to start with the main x cubed like this. And to get it to go to the right, you have to subtract 3 inside the parenthesis. And then to get it to go down 4, you put minus 4 on the outside. Okay, the next one here, you start out with g of x equals x squared. And you're supposed to go to the left 6 units, so put plus 6 inside the parenthesis. Reflecting it over the x-axis. So what you have is the x-axis here, and you're taking top to bottom and bottom to top. That's a vertical reflection. So put a minus sign outside. And then up 9 units, just put plus 9. Okay, the next one here, you're going to start with a horizontal stretch and then a vertical stretch. So we're going to be multiplying quite a bit of stuff here, okay? So I'm going to go ahead and put my x cubed, my basic function there. And to get the x to stretch 3 times, I have to put 1/3 inside, because you remember you're going to take the reciprocal of that to figure out what's actually happening to the x's. And on the outside, you're trying to stretch it vertically and multiply the y's by 4. So you just do that. You just put the 4 out there. That's where it goes vertical, and you don't have to change anything. So just put the 4 directly in. All right, on the next one, we're supposed to reflect over the y-axis. Let me show you what that looks like. You're reflecting from one side to the other over the y-axis, and that involves just changing the sign of the x. So we're going to do that first. Here's the original, and we're going to change the sign of the x, and then we're going to compress it vertically by 1/2. Vertical, I have to put it outside here, and you just put 1/2 out there, multiplying by 1/2. All right, the last one here, we're going to start out with a basic function. It's going to be a copy at the start of the parent function, like that. And you can see I just copied that, x squared. but we're supposed to go 5 units to the right. So I have to put a -5 inside the parentheses there. I didn't do a very good job there, but let me clean it up here, excuse me. All right, so x minus 5 squared. Then you compress it vertically by a factor of 2/3, it says, and finally down 2 units. Okay, on this next section, they give us a graph, and we're supposed to change it to a new one by those transformations. Well, the first thing in here is horizontal reflection. We're changing the sign of the x, and we're going to double the height and take it 3 down. So you have to do it in that order. Switch sides left and right, double the height, and 3 down. So I'm going to color code. Let me see if I can do this. I'm going to start with I think I can turn a green point on. I'm going to take this green point and show you where it ends up. I'm going to briefly, so you can see where I'm going with this, I'm going to touch the screen. So switch sides. In other words, we're going to do this. And that'll take me from +6 over here to -6. I'll erase that point later. You really shouldn't put these down, but I don't have any way of showing you otherwise. Then you double the y value or the height, so it's going from 2 up to 4, and I'll cross this off. And then it goes down 3 units, which puts me finally right down there, and let me erase everything that's not going to stay. Okay? So now I'm going to switch to a red dot, and I'm going to do this vertex up here. This vertex switches sides left and right, so we are 3 to the right, now we're going to go 3 to the left. And then you double the height, so we're no longer dealing with that one. And then you go down 3, and you're no longer dealing with that one. So let me erase the ones we don't want. And then I'm going to do a black one here, make it really prominent. And it switches sides from left to right this time, so it ends up over here, and that's because of that negative sign there. You're changing the sign of the x. And then you double the y value, so from -3 down to -6, and that one's now no longer used. And then down 3 units, so it takes you down to there. And let me erase the ones that we're not going to use. Now, you're better off actually, you're better off not putting the intermediate ones, just the final ones, but I don't have any way of showing you that. So it goes green to red to black, green to red to black. Now I'm going to assume you're not going to use colored pins or anything like that. So you could label this one A, and this is this partner A prime, and this one B, and B prime is over here. And then when we took C and did all the stuff with it, it went down here. So you connect C to A to B, and you can see that I did that on the other one also, C to A to B. Okay, similar exercise over here, but there's different actions described here. First, you move it 3 to the right. Then you cut the height in half. Then you flip it vertically and drop it 5. So let me take you through all of those. I'm going to start with this one here. I'll call it A. You take it 3 to the right, which would put you there. And then you chop the height in half, which puts you there. So this one's no longer valid. And then you change the sign of the y value, which instead of coming down here to -1.5 goes up to +1.5. And then you go 5 down. So let me erase a few things, and you can see I'm going 5 down. 1 would go 2, 3, 4. It turns out to be right there, and that's your A prime. And I think that's going to be the hardest one we deal with here. So, okay, now I'm going to do B prime, B, and we'll see where this goes. Okay, the first thing is 3 to the right. That takes me to here. And then I chop the height in half, or the y value in half, so that takes me down to here because we're up at 2.5. And then I reflect it vertically, so this negative on the outside changes the sign of the y value. It's currently up at 2.5, so that goes down to 2.5 instead. And then you go 5 down from there. So I count 1, 2, 3, 4, 5, and that's B prime. And I'm going to erase all the other stuff here. So all this gets erased, all that gets erased. Okay, so I have A and B prime. Now I got to find C, and I'll label it C, and we'll find C prime. So first thing is 3 to the right. Then you chop the height in half. That takes me down to there. Then you flip it over the x-axis, which goes 1 down instead of 1 up. And then you go down 5. 1, 2, 3, 4, 5. It puts me right there. And I'll erase all the other stuff. Otherwise it gets really confusing. Now that's C prime. And A, B, and C are connected in order, so it's going to be A, B prime, C prime. And there's our final answer for that part. Okay. Last but not least, we have a piecewise function we have to graph. And we're going to start with this domain, numbers that are less than or equal to -3. So I'll do that here. And I'll say -3, -4, -5, -6, -7, and -8. And there could be millions more, including the ones between those. Now, because it says or equal to, I know that that -3 is a valid point. It'll be a solid dot there. And so we're going to plug these x's into this equation and generate the y's. So -3 right here times -1/2 is positive 1.5. 1.5 minus 4 is -3.5. Or -2.5. I better check that again. Let me see. -3 times -1/2 is positive 3/2. 3/2 or 1.5 minus 4 is -2.5. Okay, so that's good. Let me plot that point 3.5 back and 2.5 down right there. And it's a solid dot. Okay, we're going to have an easier time here because -4 is easy to take half of. So -4 times -1/2 is 2, and 2 minus 4 is -2. So it's 4 back and 2 down. Okay, and let's skip that 5 and go to 6. -6 times -1/2 is 3. 3 minus 4 is -1. So we get right here. And then we'll skip the 7 and go to 8 since it's easier to take half of. When you say -8 times -1/2, you get 4. 4 minus 4 is 0. So that puts us right there. And maybe you can see you're going 1 up and 2 back, 1 up and 2 back. So this thing goes down like this. I should use a straight edge, but I don't have one handy. And that's the first part. So we got that part done. Okay, so we make another T-chart here, and we're going to use numbers between -3 and 4. You can see that right there. But the first one is actually not part of the graph, so I'll put an open dot there when I get to it. Okay, so we need to square them, change the sign, and add 8. -3 times -3 is 9. Change the sign, -9. -9 plus 8 is -1. And that's an open dot because it says that it's greater than -3, but does not let us be equal to -3. Okay, this one here, -2 times -2 is 4. Change the sign because of that. -4 plus 8 is 4. So -2 and 4. Okay, so far we've got 2 points on this parabola. I know it's a parabola because of the squared. Okay, -1 times -1 is 1. Now you change the sign to -1 and add 8, and you get 7. And then you plug in 0, and that gives 8. You plug in 1, and 1 times 1 is 1. Change the sign to -1 and add 8, and you get 7. So we've turned the corner, and we're coming back down now. And 2 gives 4. These are usually symmetrical. 3 gives -1. And we have one more. 4 times 4 is 16. Change the sign to negative 16 and add 8. So that puts us all the way down here. Okay, so that part of the graph looks like this. Okay, we got one section left, and that's this bottom, and it applies to any number that's bigger than 4. Not including 4, but bigger than 4. So if I put 4 down, and I will, we understand that that's going to be an open dot. Okay, numbers that are bigger than 4. Let's go 4, 5, 6, and 7 just to figure out where this goes. Okay, 2 times 4 is 8. 8 minus 10 is negative 2. Open dot at that point. Okay, 5 times 2 is 10. Take away 10 is 0, so that one hits right there. 6 times 2 is 12. 12 minus 10 is 2. 6, 2. Okay, there we go. And when you put 7 in, you get 4. And you can look at this and see the slope is 2, so I can just keep going up at that same slope. It goes up like this, and we'll put an arrowhead because it keeps going. And that, ladies and gentlemen, is the end of the review. So I hope this helps you. These examples were designed with your review next to me, so they're pretty closely related to the problems you have to do. And hopefully this is a good review to get you ready for the test that's coming up.